Next, we discuss about the elastic losses for the post-tension member. You know that these elastic forces for post-tension member is only applicable for the tendons which is stressed successively. If the tendons are being stressed simultaneously, there will be no elastic losses. Before we discuss about the equations for the elastic losses, we need to first understand the concept of the elastic losses for successive stressing of the steel tendon in post-tension member. Let's say now you have a total of 24 tendons being stressed in the member. These tendons is being stressed in groups of 6. That means in order to fully stress the 24 tendons, it will involve 4 times of stressing. Therefore, the tendons are grouped into 4 sets of tendons. The total tendon will be 24, 4 times stressing, and each time 6 tendons is being stressed. Now let us simulate the process. During the first time stressing, the first tendon group is being stressed. During the hydraulic jack operations, the member undergo elastic shortening, which occurs before the stress is being transferred to the concrete. The other 3 sets of tendons is irrelevant, and there will be no elastic losses happening during the first time stressing. Next, we come to the stressing of the second group of tendons. At this time, the first group of tendons has already been stressed. Stressing the second group of tendons will cause elastic shortenings of the member. This elastic shortening of the member will cause the tendons in the group 1 to undergo slight loss in terms of the pre-stressing load. However, that elastic shortening of the member causes no effect to the second group because it occurs before the transfer of the pre-stressing load onto the member. Then when you are stressing the third group of tendon, the elastic shortening of the member due to the additional pre-stressing force caused by the third group of tendon will generate losses in terms of the pre-stressing force in the group 1 and group 2. Same process goes for the fourth group of tendon. The elastic shortening caused by the group 4 of the tendon will cause the other 3 groups to undergo losses in terms of the pre-stressing force. If you see the table here, the first group of tendon will endure a more significant losses in terms of the pre-stressing force as compared to the third group of the tendon. This is why in the equation here, it is presented in the functions of the n here, which is known as the number of tendon, or more specifically is referring to numbers of the pre-stressing operations. Now that we have understand the concept of the elastic losses for the post-tension member, let us look into the equations to determine it. This is the equations to determine the elastic losses. The big N here represents the numbers of tendons. More specifically, it refers to the number of times of stressing operation. ES here represents the modulus or elasticity of the steel, which is 195 gigapascal, and APS here represents the tendon area, which is defined by the numbers of tendons times this area of the tendon. What you see here, there are 2 N here. Try not to confuse with these 2 N. In the example just now, a total of 24 tendons is being stressed by 4 times of stressing operations. The Bn will be equal to 4 and the small n will be equals to 24. The values are to be substituted into the equation here. And what you see here, the ES and APS represent the properties of the steel. Next will be the delta sigma C. It represents the stress in the section due to the pre-stressing force, which is pre-stressing force divided by the area of the cross sections of the beam, and also the effects of the eccentricity. The E, the I, and the A are the geometrical property of the concrete section. The P is the pre-stressing force. And then next, let us look into the ECMT, which is the secant elastic modulus at the transfer. This is basically the same set of equations being used for the elastic losses for the pre-tension member. The equations for ECMT is given here, which is in the functions of ECM and in the relationship of SCMT and FCM. The equations for SCMT and SCMs are given here. Again, this entire calculation step is similar as the elastic losses for the pre-tension member. Substitute all the relevant value into the equations, you are able to quantify the losses for the post-tension member. The function here n-1 per 2 and divided with the n here, in fact, is a mechanism to quantify the effects of the elastic losses to the previous set of tendon. If you look at the two sets of equations, the equations differ slightly due to the different mechanism of losses. However, both of them are related to the elastic losses. Therefore, they are sharing a similar set of the parameters.